Hello, everyone. I'm Lucas Campos, and today I'll be presenting Physics 2211 Lab 3 Black Hole. All right, getting into it. Agenda. I'll be going through the introduction slash purpose of the lab, the fundamental principles used within the lab, moving on to the GlowScript code, then possible errors, and then finally ending with the discussion questions. Also, introduction of the lab. There was two parts, and in part one, I used GlowScript to find the mass of a black hole. And the initial conditions that we were given were the mass of the star, which is 2x10 raised to the 30th power, and then the time, which is 86,400 seconds. And this is the time it takes for one orbit, and I got that by 24 times 60 times 60, and that's just dimensional analysis. That's how many seconds in a day. And then part two, uh, I used that found mass to determine the velocity of a spaceship required to escape the black hole. And overall in this lab, momentum and position update formulas were being used. And I kind of just said it, but the fundamental principles of this lab is momentum and Newton's second law. We have force is equal to dp dt, and another force is the gravitational force is negative g m1 m2 over r squared. All right, the GlowScript code for part one. First thing I did was I changed the C to make it unique to my Georgia Tech email. And over here is the constant. And the lab instructions we're given these two values. Well, we're given this value and then one day. So this is 24 times 60 times 60. Like I said earlier, that's the amount of seconds in a day. And then this is just the mass of the star. Moving over to this side, change the P initial and P final. Just this is simple formulas as we use in class. Same thing with this. For delta, it's just the final minus initial, and I did that for velocity and momentum. Um, Over here we have P hat is P initial over the magnitude of P initial, and then the delta magnitude of PDT. This formula, and moving on, it's just a lot of Newton's law stuff. It's for the perpendicular and parallel forces that we were trying to find, not too hard. And then over here we have the mass of the black hole, and this is just rearrangement of the gravitational force formula. So the magnitude of the net force times magnitude of the star positioning times magnitude of star positioning over the gravitational constant times the mass of the star, and this will find us the mass of the black hole. And it's just formula rearrangement. And then I had to change the arrows for the vector lines, and I just made the scale, just kind of trial and error this, and then all this was just editing it to make it actually visible. And using the code from the last slide, we can see now the results is it completed its orbit, and we have here, so it completed its orbit, and then here we have the mass of it, so 1.0179 e to the 34th power, and it's the mass of the black hole. And then we have the net force, parallel force, perpendicular force, and yeah, we get this result from the code. Moving into part two of the lab, don't crash. First thing I did was I used a starter code and I edited the mass I just found in part one of the lab, and I created the planet's velocity and planet's position, just using position update formulas, change momentum formulas, um, ship velocity, ship position, same thing. And then moving over here, we have how to find the radius, planet position minus the black hole position will find us the radius. A lot of this is the forces of the black hole on the planet and the ship on the planet. It's all just force of the gravitational force, and it's just inputting all the values that was found in other lines of code and just kind of what was given to us and just manipulation, nothing new. And then yeah, radius of the black hole ships, planet position minus the black hole position. It's all the same. And then yeah, kind of same thing for down here, just gravitational force manipulation. And yeah. Results from part two, I got that the initial velocity needed was negative 3.1 e to 7 and 2.61 e to 6 meters a second. And this visual appeared. Possible errors, run the program for a longer period of time for more accurate average mass in part one. So if I just kept running it, then I'd keep getting more accurate mass, and then trial and error in part two for finding initial velocity. It was a lot of experimenting and seeing which numbers worked and which numbers didn't. Further discussion questions. First one, the rate of change of the momentum has a direct relationship to the rate of change of velocity, and it's because mass is a constant value. And we see that the total force, F net, is acting while acting on a body. They're different, but they should be the same value when like the gravitational force is acting on and against each other. And then second question, if I wanted to reach full orbit around the black hole instead of escaping it, the velocity of the planet in my system had to be x is negative 3 to the 1, 3.1 e to 7, and y 2.6 e to the 6, and the time interval was increased, and this was I also had to increase the time interval to allow enough time to complete the orbit, and this was done in the GlowScript code, and then this visual appeared. That wraps up my lab 3. Thank you for listening. I hope you have a great day.